Hello, my name is Carlos, and today we are going to talk about of how to fit a first order model with delay to the step response of a system. This is for the class of Control Engineer Laboratory. We are group number 3, and let's start. In this slide, we see three different equations for the first order model. We know that they are a mathematical representation of how a process or systems behave over time. We have an equation of 0, 3. We have a first order system with a 0. And finally, a first order system with a non-zero. They are used for many cases, mainly they are used for single pole mathematical representations and ordinary first order differential equations. One of the most common cases are the RC circuit, which are the main basic system representation of this model, and it's important to know that they are on these three equations are only applied with no delay. To consider a delay, we have this mathematical representation of the system output over the system input represented by the alpha, yes, and our gain, in this case, the gain of the system represented by a k, yes, divided by our time constant, in this case considering like this expression. Obviously, as we said that this is considering delay, we have to add it. This is multiplied by the constant e over tau. Yes, this is considered our delay of the system, and this equation will be important to represent our exercise in a short period of time. We need to know that these kind of systems are important for chemical and industrial processes. We can represent the transportation or how the product is made to stabilize them. To start, we obtain these two graphics. These two graphics were obtained from this URL, this source, and in the first one we can see our common model with delay. As we said later, we are considering this delay as a tau, and in both cases we can see that in both cases, in this case the step response start and it pass a period in which the system start its process. However, when we not consider a delay, it's a little bit easier, and we can see the difference between these two graphs where the step response start and the model starts with its process. Let's make an exercise first with no delay. Considering no delay, we have this exercise where we have this exercise considering, first we are not going to consider it, so the delay, so let's assume that the graph starts like this. Yes, no delay. So we have here our three formulas that we explain later, and we know that our tree is equal to this. And let's get the function, the transfer function of this system considering no delay. Yes, so that these kind of processes are very easy. We know that the time period is equal to 2 over 4 according to this formula, and we have a period of 0.5. Okay. Then we know that the transfer function will be equal to the final magnitude of the system multiplied by the gain over the amplitude of the step response. In this case, we can see that this value is this one and this is this one, and if we make these calculations, we determine that our k is equal to 5/3. As you see, these kind of processes are very easy to determine, so we have no problem converting a system without delay to a system with delay. We have another variation in this kind of systems. So let's consider, yes, I already put here our function that describes the behavior of a step response with delay. Now we can consider that the step response is over here and it starts at tau period of time. So we have to get both cases in which we have our tau plus the time over 3, the period over 3, and the time plus tau plus 3, which we assume that is the delay time. Of obtaining this, we know that, obtaining this, we know that the transfer function will be now equal to our 5/3, that it's our last key that we obtained in the slide before. Yes, and we know that according to the values obtained in here, yes, considering the delay of the response, we know that yes, multiplied that we see over here. Yes, we obtain that our RC is okay. Let's graph these values to know where are located. We know that at this time we just have to 3.16, and the value is in here 1.2, and the values over here in 1.415. Yes, is equal to 1.25. So there we have it. This is the way of how you adapt a first order model with delay and with no delay. Thanks for your attention and see you in the next video.